This is no ordinary lathe. It's the BTM 350 bar peeling machine, built to strip imperfections off round bars up to 350 millimeters in diameter. A rotating cutter head peels away the outer layer with precision, revealing clean, uniform stock beneath. The result? Flawless bars ready for machining. Watching it work feels like sculpting steel in motion. Get ready to twist, turn, and forge with style. This is the M04 BKR blacksmith tool in action, designed for making decorative metal baskets and torsion elements. It's intuitive, powerful, and built for small-scale ironwork without requiring prior blacksmithing experience. The machine supports longitudinal twisting, used for square bars, up to 16 by 16 millimeters, or flat bars, 20 by 4 millimeters. The twisting section allows up to 500 millimeters of work length, with a single-ended clamp for flexibility. The result? Decorative rods perfect for gates, railings, and artistic metalwork. And just when you think you've seen it all, the tool surprises you with another trick. 4 square bars, 6 by 6 millimeters or 8 by 8 millimeters, are loaded into the forming mandrels. These are twisted simultaneously around a central shaft to create a symmetrical spiral. Watching the bars take shape feels like watching steel braid itself into art. Once the spiral elements are formed, they're transferred to a special jig for precise alignment and welded together into a classic metal basket. Clean, geometric, and eye-catching. Included with the tool are 2 die sets for different basket sizes and specialized fixtures for torsion. Whether it's rod, ALO6, or U8 millimeters, square, or flat stock, this system handles it all. It's metal shaping made simple, and watching the transformation is oddly satisfying. These power trowels don't just look tough, they work tough. Wet concrete is discharged directly onto a steel mesh grid. The loose lattice allows the mix to spread evenly while anchoring it for strength. Walk-behind models use spinning rotor arms with steel blades to smooth and compact wet concrete. The operator guides the machine over the surface, controlling tilt and speed to achieve a mirror-like finish. Concrete vibrators drive deep into poured concrete, using rapid oscillation to eliminate air pockets. Screed machines level the surface by dragging vibrating blades across large slabs. Ride-on machines cover wider areas. Twin rotors work together as the seated operator controls every move. Each tool works in harmony to create one thing: perfectly finished concrete, ready for the load. From molten slab to mission-critical steel, this is how Liberty Dalzell delivers. Each 30-ton cast slab is tracked, logged, and cut to spec. Giant rollers shape it under extreme heat, over 1,100 degrees Celsius and 2,000 psi. Then comes stamping, trimming, leveling, and testing. Every plate is inspected, certified, and traceable. It's not just steel anymore. It's bridges, turbines, and tank armor in the making. Wind turbine towers don't just rise, they're built from the ground up with brute force and engineering finesse. Massive steel plates are first rolled into curved shells. Each shell is welded, inspected, then stacked and joined to form a tower section. Precise alignment and robotic welding ensure structural integrity. From flat steel to towering giants, it's heavy industry with a mission: clean energy. Step inside a 128,000 square foot aluminum sand casting facility, where raw materials become precision parts. It all starts in the core room with 20 automatic core machines preparing molds using dry sand and top-grade input. The green sand lines follow 7 of them, capable of producing up to 2,400 molds per shift. Molten aluminum, melted in high-capacity furnaces at 7,500 pounds per hour, is poured into molds created by automated match plate machines. After solidification, shake out separate castings from sand. Then, 6-axis robotic cells take over deburring, followed by surface finishing using powerful wheel abraders. Every piece undergoes inspection and final machining in a dedicated shop. This is more than a foundry. It's a choreography of heat, pressure, precision, and robotics. Piercing through 20mm mild steel isn't easy, but this is where Precitech's PierceTech shines. Watch as the laser pierces the plate cleanly with minimal spatter. Sensors monitor the melt pool in real time, adjusting power and gas flow for optimal results. This smart control shortens piercing time and enhances edge quality. It's not just about getting through, it's about getting it right, down to the micron. One cut, and the massive anchor chain vanishes into the sea. Fast, loud, unstoppable. Was it planned or failed? Where raw steel becomes form and function. In this video, manual and CNC lathes tackle everything from basic shaping to high-precision turning. Before the turning even begins, molten steel is poured into molds and left to solidify into rough castings. These solid blanks are then secured onto the spindle, ready for transformation. As the lathe spins, cutting tools slice away material at high speed. Conventional gear-driven lathes offer steady torque, while variable speed types adapt to different materials. Mechanical clutch lathes bring extra control to the operator. Flatbed CNC lathes automate tasks with pre-programmed precision, while slant-bed CNC machines handle complex parts with ease. You can feel the power of skilled hands working alongside advanced tech. It's a balance of experience and innovation. Watching the chips fly as metal takes shape is strangely satisfying. Every turn, every cut is deliberate. This isn't just machining, it's craftsmanship in motion. A camshaft gear begins its journey from a raw block of C45 steel, cut, shaped, and refined through speed, control, and raw cutting power. First, the raw stock is loaded into the CNC milling machine. A 63mm face mill gets to work, cutting along at a feed rate of 2,800 millimeters per minute. The sound alone tells you it's not here to waste time. You can almost feel the vibrations through the floor as the first chips fly. That's not noise, it's progress. Next, a 40mm indexable drill takes over, spinning at 1800 RPM, pushing through the steel like butter. That kind of torque? You can feel it through the screen. Now it's time for some serious contouring. A 16mm WODEX Eco Mill Cutting at a velocity of 190 meters per minute and a feed rate of 1,250 millimeters per minute cleans up the profile. The rotation and cutting look hypnotic, like steel being sculpted by speed. With each rotation, the camshaft gear starts revealing its future, layer by layer. Then comes the 8mm WODEX EcoMill. This one's moving at 8,000 RPM. You know it means business. The detail work begins. A 26mm indexable drill steps in next, drilling with 2,800 RPM. The chips curl out like steel confetti. Switching to a 12mm WODEX EcoMill, the feed accelerates to 1,600 mm per minute at 5,400 RPM. Edges sharpen, surfaces smoothen. This part is evolving fast. If you blink, you'll miss the transformation. It's that fast, that clean, there's no slowing down. Now a 10.2mm WODEX EcoMill kicks in, cutting at 2,500 RPM with a feed of 3,750 mm per minute. Each pass is clean, intentional. Precision increases further with a 20mm WODEX EcoMill cutting at a VC of 400 meters per minute. This thing glides over metal like a hot knife through ice. Every cut brings it one step closer to becoming a high-performance component. No guesswork, no compromise. The final milling uses an 8mm finishing cutter at 8,000 RPM and 2,000 millimeters per minute. This is the fine touch, the difference between industrial and immaculate. Every edge, every curve is brought to its final form. To wrap it up, a Titex M12 thread tap creates perfect threads. No burrs, no second chances. From raw metal to finished camshaft gear, the entire process blends brute force with finesse. You're not just watching machining, you're witnessing craftsmanship at 8,000 revolutions per minute. Before a jet takes off or a satellite launches, it starts here, in wax, fire, and molten metal. The secret lies in a 5,000-year-old technique, refined for modern precision. This is investment casting in action. It starts with a wax pattern, either injected into a mold or 3D printed. Baron Industries delivers rapid prototypes in as little as 10 days. Multiple patterns are then attached to a central sprue, forming a wax tree that channels molten metal to each part. Next, the entire tree is dipped in ceramic slurry and coated with sand. After drying, the process repeats several times, forming a layered shell. A 6-axis robot ensures consistent coating, even on intricate parts. The wax is then melted out in a burnout oven, leaving a hollow ceramic mold. Molten metal, like 17-4 pH stainless steel, cobalt, or armor-grade alloys, is poured into this preheated mold using induction melting. Once cooled, the shell is broken off and the parts are cut from the sprue. Gates are ground away and surfaces cleaned or polished. Compared to sand casting, this method delivers tighter tolerances and finer details, often with no machining needed. And just like that, you're holding a high-precision part shaped by heat, timing, and craftsmanship. Steel rails don't just roll off the line. They're forged through heat, force, and precision. After RH vacuum treatment and ladle refining, blooms are cast by a 6-strand continuous caster. The 7-stand universal mill then shapes them, followed by online heat treatment for toughness. A hydraulic walking beam furnace ensures stable microstructure. Finally, automated sawing, drilling, and ultrasonic inspection guarantee each rail meets strict standards. This is modern rail manufacturing, heavy, high-tech, and highly automated. This is the final milestone at Wasquatim Generating Station, lifting a 150-ton turbine runner into place. Suspended with care, the Unit 2 runner descends slowly, guided by inches. The margin for error? Practically zero. Inside, this massive component channels the raw force of water into electricity. The team, construction managers, mechanical engineers, moves with absolute focus. Every bolt, every alignment has to be flawless. It's not just about power, it's about precision under pressure. And with this final lift, the station nears full generation capability. Heavy lifting, high stakes, and a moment of quiet triumph. Clean lines don't happen by accident. They're built step by step. This miter system makes joining countertop edges seamless, almost invisible. It starts with precise cuts. Edges are trimmed at perfect angles for that flawless fit. Next comes clamping. A dry fit test ensures everything aligns like a puzzle. Then the bond. The adhesive flows in, locking the pieces together. No gaps, no shifting. After curing, the edges are polished until they shine like one continuous slab. The final result? You wouldn't even guess it's a joint. This isn't just about making countertops. It's about crafting with intention, where geometry meets glue and form meets function. And with every step, what once looked like separate pieces now becomes something whole. Big valves mean big pressure, so every bolt counts. This 32-inch Trunnion-mounted ball valve starts with careful alignment of the body halves. The ball is seated, seals inserted, and the stem locked in place. Torque specs are followed to the letter. One mistake, total failure. That's why this isn't just assembly, it's responsibility in motion. This isn't your average forging. With a pneumatic hammer, each grind ball is hot-formed, lever or pedal-controlled, delivering precise blows for strength, density, and uniformity. Behind every high-speed axle is a process that's anything but ordinary. It takes 13 steps, from end-facing, roughing, and finishing to cold rolling and precision grinding. The grinding stage ensures ultra-tight tolerances critical for high-speed stability. After washing, every axle undergoes dimensional checks, labeling, and ultrasonic testing to detect internal flaws. Only those that pass make it to final unloading. It's speed, strength, and strict standards, on repeat.